Hey guys, Dr. Yu here. Today we're going to look at how to critique scientific explanation using logic and evidence. You are expected to have the following skills. First, you need to be able to identify a logical conclusion based on the evidence and data provided. And second, you should be able to identify the stated cause and effect in the scientific explanation. And last, you need to be able to evaluate evidence that supports a scientific explanation. So I will have some practice questions on these objectives. So we're going to go over some of the basics. You need to know what are the factors that you need to pay attention to. All right, first, you need to know how to draw an appropriate conclusion. Now, in order to draw a conclusion, we have to have sufficient data, right? So in the question, if you don't see enough data, then you might not be able to draw any conclusion. And also the data should be reproducible, right? That's a very important aspect of science, right? The data a scientist produces should be reproducible for other scientists. So other scientists, if they repeat the experiment, they should get more or less the same data and the same conclusion. So that's the two things that you need to kind of consider when you draw conclusions based on the evidence and data provided to you on the question. You will be asked to evaluate the experimental procedure and data, and then draw a conclusion. Again, later I'll show you an example. So I made up some data, and then you can look at data and see what kind of conclusion you can draw based on what's provided to you. Second, identify cause and effect relationship. So in the TEAS study menu, they mentioned one example, which involves the use of different fertilizers and to determine what kind of effects they have on grass growth, right? As you can imagine, different fertilizers will probably have different effects on grass growth. Some fertilizers may lead to faster growth in the grass, and some fertilizers may not be very effective in terms of promoting grass growth. So if such data are provided to you, you should be able to interpret the data correctly and determine how different fertilizers affect grass growth. So based on the data, you should be able to tell, which brand or which type of fertilizer is the most effective or least effective in promoting the growth. I have a similar question in the end, made up a similar example, and you can look at the data and see if there is a cause-effect relationship, right? The cause is the different fertilizers you use, and the effect is very fast growth or very slow growth or no effect. Next is about evaluating the evidence. So when you see a study, if it's a good study, then the evidence, which are basically the data, will be very strong and reliable. These are the factors you can consider. Now, first of all, the bias is properly accounted for. So if there's any bias you think that may occur during the study, then the data are not reliable, right? So you need to do all you can to kind of remove any bias from the experiment. And one good example of how to remove bias is placebo, right? So a lot of medical studies will include a placebo group. So let's say they're looking at the effect of a drug on heart health. They're going to divide the subjects into two groups, right? One is the placebo group, and the other one is going to be the experimental group. They're going to give the experimental group the test drug, right? And then the placebo group will receive something in similar shape and color, but it does not have the drug. It does not have the active ingredient. Instead, it may have something like either sugar or starch, things that do not harm you, but they do not have any positive health effects. So then they're going to compare the outcome, right, from the two groups. If the subjects from the two groups have similar performance in terms of the heart of their health, then the drug is not effective. If the subjects in the experimental group have improvement in their heart health, the drug probably does have some positive impact on the heart. All right, so that's placebo, which can be used to account for bias. The second factor is controlled setting. So when you do experiments, you have to make sure that all the groups, whether it's a control or whether it's a treatment group, all the groups should have exactly the same setting, right? All the controlled variables should be the same. For instance, let's go back to this drug experiment. So the subjects should have everything very, very similar, except for what they ingest, right? Whether it's a sugar pill or whether it's a pill with the actual drug. But everything else should be the same. For example, how much they exercise each day, daily exercise, right? Or their diets probably should be similar because diet could also affect the heart. And maybe stress level. Okay. And the subjects could be all from similar age groups, and they can be the same gender. If you really want to reduce the variation, you can do that. Basically, we need to keep all the controlled variables the same between the two groups. And we only change the independent variable. Right? Independent variable is the variable that you want to test. And in this case, the variable is whether you provide the drug or not. Right? So the absence and the presence of the drug is what you want to test. And everything else are considered controlled variables, right? Age group, gender, the amount of daily exercise or diet, all those need to be kept more or less the same between the groups. Next is data collection. So you want to make sure the data collection is accurate. Right? For example, if you do an experiment, you are taking the readings from an instrument. If the instrument gives you a reading of 6.8, but then when you collect the data, you put in 6.9 in the data sheet, that's not accurate, right? So that will be considered a very bad data collection. It's not accurate at all. Next, replicable, reproducible results. We mentioned this earlier, right? When you do a study, other scientists should be able to follow what you did and produce similar results. Right? So if other people are able to reproduce the same results, then the conclusions would be more reliable because it has been verified, right, by another group of scientists. Large sample size and repeated trials. So the larger the sample size is, the more reliable your conclusion is, right? Because a larger sample size will take into consideration of all the variations, right, among different subjects that you test. So it will give you a more accurate reflection of the actual data. Repeated trials can, just like a large sample size, can give you a more accurate reading because you're taking the average, right? And then the average is probably more closer to the actual data, to the actual value. Okay, now we mentioned a couple of different variables. So I just want to give you some definitions so you know what they are, because on TEAS you may see a question asking you which one is the independent variable and which one is the dependent variable. Independent variable is the variable being tested. We'll talk about that. So if you're looking at the effects of different fertilizers on grass, then the variable being tested is the different types of fertilizers, right? So type of fertilizer would be the variable. You can see here a variety of fertilizers. The dependent variable is affected by the independent variable. And it's usually what's measured and what you collect data on in the experiment. So again, going back to the fertilizer and grass experiment, you are going to measure grass growth. right, under the treatment of different fertilizers. So grass growth would be the dependent variable. But of course, you can measure multiple things, right, as indicators of grass growth. So controlled variables are potential factors that could confound experimental results. And that's why you have to keep them constant between different groups. In this case, we have factors such as temperature, sunlight, concentration, and amount of fertilizers that can all confound the experimental results. So we need to put all the treatments at the same temperature, and they receive same amount of sunlight, and we need to adjust the concentration and amount of fertilizer, right? So we need to give the different groups the same amount of fertilizers. This is a practice problem. This problem is designed to test your knowledge of different variables. So let's say a group of researchers would like to study the effect of different insecticides on bee mortality. In this study, which one is the independent variable, which one is the dependent variable, and what are some examples of controlled variables that should be kept constant among different groups? Okay, so the answer is dependent variable is the effect of different pesticides, right? That's where you're testing, right? You're testing to see if different insecticides can cause different amount of bee death. The dependent variable is what you are measuring, right? So you are measuring bee mortality. So how many bees die after you use the insecticide on them? That would be A. Now, what are examples of controlled variables? Probably temperature, right? If the temperature is too high or too low, that could cause bee mortality, right? So you can't give, let's say, you gave a group A fertilizer number 1, okay? And then you gave group B fertilizer number 2. And then you put group 1 at 90 degrees Fahrenheit, and then you put B in, let's make up a crazy number, 150 degrees Fahrenheit. Okay? If all the bees or most of the bees die in group B, you don't know whether it's due to the high temperature or it's due to insecticide. Oh, this is not fertilizer, insecticide. Right, so this could be a confounding factor. So we need to keep this constant among all groups. If we decide to use 90 degrees, then everybody, all the bees, from all the groups should be kept under 90 degrees. What about food? The amount of food provided, of course, that could be a confounding factor, right? If you give A, a lot of food, more than what they can eat, and then you don't give group B enough food, then it's likely that some bees might not make it in group B, right? And again, if you see mortality, you don't know whether it's due to the absence of sufficient food or is it because of the insecticide. Colony density, that could be a potential controlled variable, and that's because density does affect the organisms, right? If the density is too high, then it's going to stress out the individuals and they are more likely to die. Next question is a very long question, has multiple parts. So here's the background information. Maybe you can take a screenshot and then keep it open on your computer so that you can use this information to answer the questions on the following slides. I have a typo here. So a researcher is studying the efficiency of using different vertebrate species to remove algae. Some algae can release toxins, and those toxins can kill fish and some of the other aquatic organisms. So this researcher has a goal to find a species that eats the algae that produces toxins. So she selected 3 species, A, B, and C, to test their efficiency to control algal growth. Now, basically, whichever species that can eat the most amount of algae will be the winner, right? That's what the researcher is trying to look for. So the table below shows the results of her experiment. So these are different species. And reduction in algal density after 2 hours. And the next column is a reduction in algal density after 12 hours. So based on the information, we got question 1. Which of the following is the dependent variable in this study? Remember, the researcher selected 3 species, right? She wants to see which species is the most effective in controlling algal growth. So the different types of species is the dependent variable, the vertebrate species, not the algal species. So the correct answer is C. What is the dependent variable? The dependent variable is what you measure, right? So what's measured in this study? Reduction in algal density. Which of the following variables should be controlled in the experiment? Experimental temperature, of course, because temperature definitely affects algal growth. So you want to keep all the groups under the same temperature. Invertebrate density, that's a definitely yes. And that's because in group A, you put 3 individuals of species A. Okay? And then in group B, you put in 9 individuals of species B. Now, if you see a greater reduction in algal density for species B, it could be because B is effective, right? Or it could be simply because you put in more individuals of species B in the beaker or whatever container you have. So of course, they're going to remove more algae, right? So you need to keep the vertebrate density the same across the different treatments. C, initial algal density. Yes, right? If you, let's say you put in, let's say 10,000 for species A, and then you only put in, let's say 2,000 for group B. So again, if in the end you see a greater reduction, is it because B is effective, species B is effective, or is it because you simply start with less algae, right? So in the end, you're going to get less algae. So C is also a correct answer. D, type of experimental medium. Yes, because different media may affect algal growth, right? The algae may prefer certain media and they will grow faster. So you need to make sure that all the treatments receive the same media so that you know that the media is not going to affect your experimental results. So the correct answer is E. 4, based on the results, which of the following statements is correct? So we need to figure out which one is the best species to remove algae. And then we need to figure out whether it's the short term, 2 hours, or is it the longer period, which is 12 hours, I believe. So let's look at the original table. Okay, so for 2 hours, looks like A and B have a similar efficacy. And after 12 hours, again, A and B are leading C, but B seems to reduce the most amount of algae, right? Because it's the reduction in density is 7,000 cells per cubic centimeter. So for C, this reduction is 1, and after 12 hours, the reduction changes to 0, right? So that means C is not very effective at all, because if you give it more time, the algae will kind of grow back to the original level. All right, now let's go back to the questions. Species A is the best species to remove the algae during the first 2 hours. Now remember, A and B both reduce the density by 2,000 cells, right, per cubic centimeter. Remember the number 2 for both A and B. So A is not the best species for the first 2 hours. Species B is the best species to remove the algae during the first 2 hours of the experiment. That's not correct either, right? Same reason. A and B were equal in their efficacy to remove algae for the first 2 hours. Species C has little impact on algal growth. That's what's shown in the data, right? After 12 hours, the reduction in density is 0. So this might be the correct answer. Species B, the best species to remove the algae during a longer period of time. That's also correct, right? If you can see, after 12 hours, E is leading both A and C. So this statement is also correct. Now I should make this select all that apply, because we do have multiple answers. Select all that apply. Species C has little impact, and species B is the best species to remove the algae during a longer period of time. So we're talking about 12 hours. That's all we can infer from this study, right? If, let's say, I change this to during, let's say, 2-day period, would the D still be the correct answer? No. If I change it to 2-day, only C is the correct answer. And that's because from the experiment, they only did 2 hours and 12 hours, right? So their data actually do not tell you anything about what will happen, at the end of 2 days. So if I change this to 2 days, then this is not going to be a correct answer. All right. So that's this lesson. We're almost done with the TEAS review.